Okay, let's start by setting t equals 0, which means that we're not going to be toggling the functions. So with that, ideally, we're going to get that q plus is equal to q, like your previous q. So for right now, let's say that q is equal to 1, and not q is equal to, or actually, let's do this. Our previous q, which is this point over here, we're going to set that equal to 1, and this point over here, we're going to set that equal to 0. Right? So here, our input is t, which is 0. And for the very top gate, we're pulling from not q, which previously was a 0. So that's 0. And for the bottom gate, we're pulling from q, which is a 1. 0 nan 0 is 1, and 1 nan 0 is also 1. So the input into both of these NAND gates is a 1. Now, this point here is a 1, so we're 1 nan 1, that's going to be an output of 0. And the value over here is also a 0, which 1 nan 0 gives you a 1. And so our previous q was 1, and our next q is also 1. Our previous not q was 0, and our next not q is also 0. So when t is equal to 0, your q value holds, and so then this is true. Okay, now when t is equal to 1, we want this to toggle. So ideally, our next q should be equal to our current q minus, or basically not q. And then our next qn is equal to our current q. So let's say that our q value right now is a 1, and our not q is a 0. Our t input goes in as a 1 into both of these inputs. Our not q value comes up here, which is a 0. And our q value, which is a 1, goes over here. 0 NAND 1 is a 1. 1 NAND 1 is a 0. We have 0 as an input here, 1 as an input here. Into a NAND gate, if you have any 0 input, that means the output is always going to be a 1. So already we can see like a toggling here. So our old not q value was a 0, and our new one is a 1. Now this new value of 1 is going to go up into this gate. 1 NAND 1 is a 0, and we see that the q value has also been toggled from 1 to 0. So that means this is also true when t is equal to 1.